This is highly efficient three-port bidirectional converter with partial power processing stages. What is partial power processing stages means the power will be processed, that is either AC to DC conversion or DC to DC conversion or DC to AC conversion. The power will be processed partially. Other than that, the power will be allowed to flow through to the load directly without any processing. Here if you see means initially AC supply will be on, and that will be provided to the battery until the battery voltage is lower than the higher than the AC voltage. If the AC voltage is increased higher than the battery voltage, that is it goes more than the battery voltage, then it goes through the bidirectional buck boost converter. Here from grid to battery, the buck operation will takes place. This buck switch will operate. So at the time, the battery voltage will be maintained here, even though grid voltage is higher due to this buck operation. And in reverse, that is when the grid is disconnected, we have to supply the load. At the time, battery will act as a source and the power flow will be reversed. At the time, here the boost operation will takes place, and here it will be provided. That is, until the AC voltage reaches the battery voltage, it will be directly provided. After that, if the reference voltage is higher than the battery voltage, it will goes through this boost converter operation. Here a bidirectional switch is used for positive and negative cycle. That is, initially the power will flow through this bidirectional switch, and when the AC voltage becomes higher than the battery voltage, it will go through this rectified and it will go through the buck switch. So buck operation will takes place and the output voltage will be reduced, and it will be same as the battery voltage. Similarly, when battery is discharging, it goes through this bidirectional switch and provided to the AC load until the reference voltage is lower than the battery voltage. When it goes higher than battery voltage, then the battery voltage goes through this boost operation. So the voltage will be boosted and the boosted voltage will be flowing through the AC load for both positive and negative cycles. Here this is for rectifier and also for the bidirectional switches, and this is for the buck and boost switches. So two separate controllers we are using. Here if you see the outputs, inverter voltage and inverter current, until zero point 0.5 seconds the grid is providing the power to the battery will be charging. After zero point 0.5 seconds grid will be disconnected, so the battery will provide the supply to load. Here 5 level operation, that is 160 volt is the battery voltage. So if it goes higher than that, then the boost operation will takes place. Until then it will be provided directly. And second one is current, inverter current. And here this is the RMS value of the inverter current. Initially it is around 4 amps. After that, when battery was discharging, it is 1.5 amps. It will increase according to the load. And this is the DC bus. Initially it is around 200 volt. After zero point 0.5 seconds it is increased to 220 volt. Similarly, initially it is flowing in the forward direction 2 amps, and after zero point 0.5 seconds it is going in the opposite direction. That is, the battery was initially charging until 0 to 0.5 seconds, and after 0.5 seconds the battery will be discharging, so the current will flow in the opposite direction, minus 1 amps nearly. And these are the battery voltage, battery current, and the state of charge. The voltage is around 160 volt, and here initially the battery was charging. After zero point 0.5 seconds the current direction is reversed, nearly 1.2 amps or 1.1 amps we are getting. And third graph is state of charge. 10% is the charge, initial charge it is given to the battery. Here it is increased to 10.002, 004, 006, and after zero point 0.65 seconds the grid is disconnected, so battery have to provide the supply to AC load. So the battery state of charge decreasing because battery is discharging here. This is the working. That is inverter voltage, DC bus voltage, battery voltage, SOC, and here this is the efficiency. Input power, output power, efficiency. Efficiency is around 98 percentage, 98.9 percentage efficiency, and power is around 440 watts. Input power and output power both are almost same. So this is highly efficient partial power processing. Bidirectional converter. The battery will be charging initially when grid is connected. When grid is disconnected, the battery will be providing power to the load. So we can get bidirectional converter operation. And with partial power processing stages, it depends upon the battery voltage and grid voltage. If the grid voltage is lower than the battery voltage, it can be directly provided to battery, and if the grid voltage is higher than the battery voltage, that is when it crosses the battery voltage, then using the buck operation we will reduce the voltage and maintain the load voltage. And in discharging operation also, when the reference voltage is lower than the battery voltage, the battery will provide the energy directly, and if the reference voltage becomes higher than battery voltage, at the time through boost operation the battery will provide the power. By using this we can reduce the processing time, power processing time. By reducing the power processing time we can increase the efficiency because losses will be reduced. Yes, only little time the bidirectional converter operates. Okay, this is the working.